So 1 mole of this. Those are your initial moles. 1 mole of this and 1 mole of this are mixed together. And they're allowed to reach equilibrium. So initially you did not add any of the ester, which is over here, and there's no water molecules right now. So those are your initial moles. And then he says, anyways, that's the type 2 question. Let's ignore that. Okay, hold on a second. Let me open this one. Actually, 1 second. This one. Let's even try the difficult questions. This one, for example, you've got. Okay, let's warm up with a normal, simple question. Not this one. We can start with this one. So this is the reaction, and you're being asked that there's 2NO2 reacting, and they're in equilibrium with 2NO and plus O2. And initially, there's 4 moles of nitrogen dioxide. So I think this is 4 moles. Those are your initial moles. So right at the beginning, you're adding 4 moles of NO2. And they're placed in a 1 dm cube container and heated to a constant temperature. So there's nothing else. There's just 4 moles of NO2. There's no O2, there's no NO. And then he says that the equilibrium mixture contains 0.8 moles. So once the reaction has reached equilibrium, he then says that the amount of O2 it contains, that's 0.8 moles. So based on this, I'll try and figure out what are my equilibrium moles for the other ones. So initially you had no O2, now you've got 0.8, so that means 0.8 got produced, right? So 0.8 moles got produced. So agar ek produce hota hai, it's 1:2. So 2NO will also be produced. So if 0.8 are getting produced, then that means 1.6 moles of NO must be produced as well, right? And 1 gets produced, 2NO2 react. So if 0.8 is getting produced, that means 1.6 over here must be reacting. They must have reacted. Ye clear? Is this clear? Abdullah, Rafi, Ahmed. Is this clear?
Sir, ये last वाला दोबारा पता है कि 1.6 reacted कैसे हुआ?
नहीं, ये clear है कि if you had O2, you had no O2 initially, now you've got 0.8, so that means 0.8 during the reaction 0.8 moles got produced, right? There must have been some forward reaction, like 0.8 got produced. तो एक produce करने के लिए कितने react होते हैं? 2? It's 1:2, right? So if you want to produce 0.8, right, okay. 1.6 must have reacted, right?
Okay.
Yes, Momin, what's the question?
Assalamu alaikum, sir.
Islam.
सर बेसिकली जो मैंने ये कंफ्यूजन थी इसलिए पूछ रहा हूँ कि हम जो मोल्स एक तो हम मोल रेशियो लेते हैं जो ऊपर इक्वेशन में दी हुई है हम उससे यूज करके निकालते हैं और हम इनिशियल मोल्स नहीं यूज कर सकते ना ये जो रिएक्ट करने वाले निकालने के लिए।
हाँ मतलब ये कि इनिशियल तो कोई भी आप डाल सकते हो ना। इफ यू हैव अ कंटेनर you could add any amount of NO2, you could add any amount of NO, you could add any amount of O2.
But we cannot use the 4 moles to reduce the reacting moles.
हाँ, you can't use that. You have to take the difference. के initial given होगा and they'll give you the equilibrium moles, right?
Like so in every case हमें अभी सिर्फ reacting या जितने producer है वो हमेशा पहले निकालना है।
हाँ, तो उसके अंदर से ना पहले तो you'll try and figure out कि भाई where did the equilibrium shift, ठीक है? So you figure out कि भाई you had no O2, now you've got 0.8. तो ये basically, and this is the first thing that you're going to find out, like how much is actually getting produced. तो ratio इस पे apply होगा, ठीक है? So if one is getting produced, तो उस तरह फिर निकलेंगे। और फिर you अब initial use होंगे to find the equilibrium moles. Like you had 4 moles, 1.6 moles reacted. So what are you left with? You're left with 2.4 moles, right? Clear?
Yes, sir. Thank you.
और यहाँ पे you had initially 0 moles and 1.6 got produced. So how many moles do you have at equilibrium? It's 1.6. So now you have, and remember, you can't use moles in the Kc expression. You have to calculate concentration. The container is 1 dm cube. The concentration would be exactly the same. It's going to be exactly the same. Okay. So it's going to be exactly the same. And the other thing is you just have to find the Kc expression. The Kc expression will be NO squared, which is 1.6 squared, times O2, which is 0.8 mole per dm cube divided by 2.4, and that's going to be squared as well. So the answer will be D. I think D. Clear?
Yes, sir.
Yes, sir.
Yes, sir.
Achha, let's try a difficult question. You have this question, and he's saying that. Achha, now the reason this is a difficult question is that he gave you 4 reactions, so you have to do this thing which you did over here 4 times, because every time the reaction that he gave you is a different reaction. It has a different ratio. So wo jo aapki working hogi na, every time it's going to be different, right? So that's why this is going to be kind of really time consuming. So he's asking us to figure out which is the right equation for this, for whatever data that's given over here. So you have to do trial and error, because you don't even know what the equation is. So we can start with option A. Like option A is, let's say that this is the reaction. P reacts, produces 2Q and 1R. Anyways, so initial moles, 2 moles of compound we were placed in a vessel. So initial R, you've got 2 moles. And that's it. The vessel was heated. Yani that means that you did not add any Q, you did not add any R into it. And a dynamic equilibrium between chemicals PQ and R. So eventually there was some reaction and some equilibrium got established. At equilibrium, X moles of R were present. So equilibrium ke moles are given. That's so he's saying that at equilibrium, there's X moles of R. So that information would be sufficient to find the moles of all the other ones. So if you have X moles of R, initially you had no R, now you've got X moles. So that means X got produced, right? So according to the ratio, if 1 gets produced, 2Q will be produced. So if X get produced, so yahan pe how much Q will be produced? 2X, right? And according to the ratio, if 1R gets produced, 1P will react. Same ratio, right? So if X get produced, yahan pe on this side, X would have reacted, right? So X moles are getting reacted. So now your equilibrium moles are over here. 2 shuru mein the and X got reacted. Now you're left with 2 minus X. As you had 0 moles, now you've got 2X extra getting produced. So now you have 2X moles, right? So is this working clear? Does it make sense? Unai clear? Baki clear, Rafi?
Yes,
Yes,
sir.
sir.
Achha, so he's saying that the total number of moles at equilibrium that were present was 2 plus X by 2. So X moles is 2X moles of this and 2 minus X of this. If you add up all the moles, I don't think they're going to come out to be 2 plus X by 2. 2 minus X plus 2X plus X moles of R. That comes out to be, what is the total number of moles present? That's that's going to come out to be 2 plus 2X, right? So that means that's option A is not the right option, because the data, I mean, you're not getting this. So you're going to start with the next option. Okay, let's assume that same data, everything is the same, but the ratio is different, so the working will be different. So I'll rub all of this.
Sir.
Yes.
Just saying, sir, I think A was wrong from the beginning, because in the question they mentioned 2 moles of P were placed, right?
No, it's, remember,
so that means 2P.
no, it doesn't mean it's 2P. You could place any moles of P. I mean, the equation actually gives you the ratio. It's not about, I mean, if there's 1P, that doesn't mean you have 1 mole of P. It just means that the ratio between the particles, right? So I'm going to try B now. It's 2P and 2Q and there's R, right? So now again, same thing, X moles getting produced. So 0 moles initially. So that means X got produced over here, right? Now it's R and Q, it's 1:2. So if 1 gets produced, 2 of this will be produced. So 2X over here will be, it's going to be produced, right? And 1 gets reacted, 2 over here, 1 gets produced, 2 over there will be reacting, right? So 2x moles over here will react. So your final moles will be 2 minus 2x over here. You had 2 moles and 2x reacted. So you're left with 2 minus 2x. You had 0 moles and 2x moles got produced. So you have an extra 2x moles now. And again, you're never going to get, if you add up the moles of this and this and this, the total moles will not come out to be 2 plus x by 2. So that means B is not the right option. And so you would have to do trial and error again. The correct option is D actually. So I'll just tell you why it's D. We can do the working for D. We can just skip C. So there's no shortcut to this answer. You would have to actually do this on each one of them. Now, the ratio is different in this case. It's 2p and 2r, right? I said the hint was, I mean, you could have done it directly, but that, I mean, it would be very hard to actually figure out directly. I mean, because there was an x by 2, right? So if you have x moles of r getting produced, so if you have x moles of r getting produced, so the amount of Q will be half of that. It's 2:1, right? So it's going to be x by 2 of this getting produced. So the direct method was that if you, I mean, it would have been very hard for you, but even for me actually, to directly actually answer this one, right? Like there was a half coming in. The half is only possible in this equation because x, then Q will be x by 2 produced, right? And 2:2, so that means it's the same ratio. So if x get produced on the other side, x would have reacted, right? So you got 2 minus x moles for this one, x by 2 moles for this one, and x moles for this one. So the answer will be that the total moles at equilibrium will come out to be 2 plus x by 2. If you add all of the three together, then it's going to come out to be 2 plus x by 2. Is that clear?
Yes, sir.
ठीक है, बाकी clear, Rafi clear?
जी सर.
This question is exactly the same. The only thing is now he's asking for 2 plus x. I think the answer is B. I mean, I'll just quickly do this. I think it's B. Wait a second, B. Shayad B. Let me just quickly do this. 2p equilibrium, that's 2q plus r. Initial moles, again, it's the same 2 moles initially, and 0 moles of q and 0 moles of r. At equilibrium, you have x moles of r. So x moles of r. So that means x moles got produced. I'm just going to write plus x. So this will be plus 2x, right? It's 1:2. And on the other side, 2x would have reacted. It's going to be minus 2x. According to the ratio, x getting produced, 2x of this will get produced as well. And on the other side, minus 2x would have reacted, right? Same ratio. So the moles over here will be plus 2x, and the moles over here will be 2 minus 2x. You add up all of them together, the final total moles, total number of moles, you add this, and add this, I think you're going to get 2 plus x. So that is the correct option, right? So this was kind of the same question. Now here's another question about Casey, which is now, as we did this last time, this one. Although it's not about, it is kind of about calculations, about calculating the value of Kc. Look at reaction number 1 and look at reaction number 2. Do you think they're two different reactions or are they the same reaction? I mean, carefully look at reaction 1 and reaction 2. Are they different reactions or are they the same reaction?
Reaction.
They're exactly the same reaction. I mean, if you look carefully, there's x2y, there's x2y. This x2y is in equilibrium with x2 and y2. This x2y is in equilibrium with x2 and y2. The only thing is that it's been balanced differently. I mean, the two equations are like this. You have an equilibrium reaction, A in equilibrium with B. The other one is, it's just written differently. They're saying that B is in equilibrium with A. And they've balanced it differently. I mean, they put a half over here, they put a half over here. So the two reactions, although they are, I mean, the equations are different, but they're kind of the same reaction, right? Is that clear? Your point clear? I mean, these two are kind of the same reaction. Is that clear?
Yes, sir.
Yes, sir.
So they're kind of the same reaction. Will they have the same value of Kc? Because they are the same reaction. Will they have the same value of Kc?
Yes, sir.
No, because Kc is expression dependent.
I don't think so, sir, because none of the answers has to.
But the thing is that because the equation is written differently, I mean, they're the exact same reaction, right? But Kc is expression dependent. Your Kc expression would be, for the first one, it's going to be the product is x2y, and that's getting squared. And your reactant is what, x2, and that's squared as well. Let's call it Kc1 into the concentration of y2. So your product and your reactants are different. So the Kc expression for the first one is going to look different, and it's going to have a different value. The second one, the product, because the way it's written, the Kc expression will be different. It's going to be x2 concentration and y2 concentration power half. That means under root. And the whole thing gets divided by x2y, right? And it's concentration. Now, so obviously the Kc expressions are different. The powers are going to be different because it's balanced differently. Plus the product and reactants are kind of switched. So the numerator method, that thing is now in the denominator on the other one. So the values are going to be different. But the two values will be kind of interlinked with each other. They will have a relationship between each other. Is that idea clear? Okay, the two values are different, but they are kind of, they have a relationship with each other. Is this clear?
Yes, sir.
Will you explain,
Yes.
what is the relationship between Kc1 and Kc2? Like, what do you do to Kc1 so that it becomes Kc2? I mean, first thing, you would have to like make it upside down, right?
Multiply the
अगर Kc2 को हम स्क्वायर कर दें पूरा और रेसिप्रोकल ले लें तो Kc1 हो जाएगा.
ठीक है, so that means Kc1 is basically, ठीक है, that means Kc1 जो है, that's make it upside down, Kc2 को, ठीक है, but x2y should be on top and this thing should be at the bottom and it should be squared, right? Like if I square it, it becomes exactly this. Okay, it will become x2y squared, x2 squared, and y, this would become power 1. ठीक है, ये clear? I mean, that's the relationship between the two. Is that clear?
Yes, sir.
Yes.
And they gave us the Kc for reaction number 1, which is 2. So that means 2 is equal to 1 over Kc2 squared, right? I mean, they gave us the value for Kc1. So बस वो क्या होगा? That's going to be, I mean, find Kc2. It's going to be 1 over 2 under root, right? I mean, take this to the other side. 2 इधर आ जाएगा. Take the under root, and Kc2 will be under root 2. Under root 1 over 2. Is that clear?
Yes, sir.
तो बस ये ठीक है. उन्हें clear है?
Yes, sir. Yes.
Asha, so some more questions. Asha, we'll do a difficult question as well at the end. We'll just do one more easy question. Did we do this one? I don't think we did this one. Here's an equilibrium which is x in equilibrium with 2y. So that's an easy one. It's x in equilibrium with 2y. And the initial concentration that's given is 0.5 mole per dm cube for x. So that's your initial. So it's 0.5 mole per dm cube. And there is no y. Uske baad hi wo keh rahe hain equilibrium has been reached, right? So there's no y initially. And then he says that when equilibrium has been reached, the concentration of x falls to 0.25. So at equilibrium, it's 0.25. So that means how much of it reacted? 0.25. minus का मतलब 0.25 reacting, right? So if 0.25 are reacting, right? So on the other side, how much will get produced? It's 1:2. So 0.25 is reacting. तो यहाँ पे कितना produce होगा? 0.5 will get produced, right? Is that clear?
जी sir.
Yes.
Yes.
So आपके जो equilibrium moles होंगे ना, that's going to be 0.5 because initially you didn't have any y. Now you've got 0.5, so you got 0.5. And you have to calculate the value of Kc. It's going to be y squared, which is 0.5 squared, divided by 0.25 and power 1. तो 1 ही आएगा, ठीक है? So your Kc value is going to be, it's going to be 1. And you have to pick the right graph as well. So what is happening to your concentration? X concentration initially is 0.5 and it falls to 0.25. So ये दोनों graphs ठीक हैं. X goes from 0.5 and falls to 0.25. X goes from 0.5 and falls to 0.25, right? Y is 0 से start होता है and goes all the way up to 0.5. So I guess C is the right graph. कि Y जो है ना, that's starting at 0 and goes all the way up to 0.5. Those or X starts at 0.5 and its concentration falls to 0.25. So I guess C is the right graph for this, for all of this. Is that clear?
जी sir.
Yes.
अच्छा फिर ये कि we should do this one as well. I told you, what did I tell you about solids in a Kc expression? If you have a solid,
We ignore that.
we ignore that. ठीक है, when the solids don't have, I mean, you take it as a constant concentration. So in this case, your Kc expression will not have silver solid in it. तो उससे कहा है कि silver ions के जो moles हैं, that's 1 mole. So initially you have 1 mole of this, and you got 1 mole of Fe2 plus. This is Fe2 plus. So you got 1 mole of this in a 1 dm cube solution. So there's no silver, there's no Fe3 plus. Equilibrium was established. There was 0.44 moles of silver ions. So equilibrium pe na, this is 0.44 moles. So how much reacted? 1 tha shuru mein and you got 0.44 now. So that means 0.56 are gone. 0.56 have reacted. And it's 1:1. So 0.56 of Fe2 plus would also have reacted. Wo bhi gaye. So you started off with 1 mole, now 0.56 are gone, so you're left with 0.44 moles. And if 0.56 are reacting with 0.56, it's 1:1. So udhar jaake 0.56 will get produced. So you're going to get 0.56 over here, and 0.56 of this will also get produced. So final equilibrium moles for this will be 0.56. This will also be 0.56. And remember, you don't use moles, you use concentration, but they gave us a 1 dm cube container. So the concentration would be exactly the same. The Kc expression will be 0.56, and at the bottom it's going to be 0.44 times 0.44. वो 1.56 जो है ना उसको आप remove कर दोगे because a solid will have a constant concentration. You're going to ignore that. ठीक है, is this clear?
जी sir.
Yes, sir.
The solid's going to ignore.
Yes, sir.
क्या value आती है? Is it, what is this? This is
Yeah.
C या D?
D for dog.
ठीक है, तो D है. अच्छा, so अच्छा मुश्किल वाला question, ठीक है, just one difficult question structured. I guess कहाँ गया? Just 1 second. Kc, ये कौन सी worksheet है? हाँ, ये वाला question. Now this question is kind of like moles and Kc mixed together. So there's an alcohol reacting with a carboxylic acid in equilibrium with an ester and a water molecule, right? To write an expression, product over reactants, you can write that. Uska koi unit hoga. Now there's an experiment that goes on to determine a Kc, and a student placed together in a conical flask 0.1 moles of ethanoic acid and 0.1 moles of an alcohol and 0.005 moles of HCl. So imagine karo ke you've got this conical flask, right? What are you adding into the conical flask? You're adding 0.1 moles of ethanoic acid, right? So you're adding 0.1 moles of ethanoic acid. And you're adding 0.1 moles of ethanol as well. अच्छा बीच में ना acid catalyst भी add हुआ है, so you're adding 0.005 moles of HCl as well. So इसी के बीच में you're adding what does the catalyst do? It doesn't affect the equilibrium position. So 0.005 moles of HCl is also added. And now he says the flask was sealed and kept at 25 centigrade for 7 days. After this time, the student titrated all of the contents of the flask with 2 mole per dm cube NaOH using phenolphthalein indicator. At the end point, 22.5 cm cube of NaOH was added. So he keeps the flask sealed और इसके moles change हो जाएंगे. अच्छा इन सारों में whose moles will not change out of all of these? I mean, there's definitely HCl. Remember, a catalyst does not react and it remains unchanged, right? So even, I mean, the moles of the ethanoic acid and ethanol will change. Obviously, there's going to be some reaction, so the moles will decrease. And the moles of the ester will be higher. Abhi to hai nahi, so now some ester will be formed, right? And some water molecule will be also formed. Now he's reacting the whole thing, titrating it with NaOH. Okay, so the whole thing is being titrated with NaOH, and he's told us that kitna NaOH used with 2 mole per dm cube. Like that's the concentration of NaOH. And he's told us the volume of NaOH that has been used up. That's 22.5 centimeter cube. Now, first part, he's saying calculate the amount in moles of NaOH. So how many moles of NaOH do we have? Here's a concentration times volume divided by 1,000. What do you get? What's 45 divided by 1,000?
Uh, 0.045.
So my moles are 0.045 moles. Explain to me, what will the NaOH react with in this whole mixture? Like he's titrating it with NaOH. वो सारे में किसके साथ जाके react करेगा?
Acid.
And you got 2 acids, right? So that means this NaOH that you're adding is going to react with ethanoic acid, whatever's left of it, okay? And it will also react with the HCl. So it's only going to react with these 2 things. In दो चीजों के साथ react करेगा. Is that clear? It's not going to react with the alcohol. It's not going to react with the ester. It will react with the acids. There are 2 acids present. So he's saying what amount in moles of this NaOH reacted with HCl? That's the next question. So HCl के moles तो change नहीं होंगे ना? What is the ratio of NaOH with HCl? It's 1:1, right? So that means out of this 0.045 moles that you're adding, how many moles are actually reacting with the HCl? कितने react करेंगे?
0.005.
That means ये जो 0.05 डाला ना, 0.005 moles they go and react with the HCl, right? Because the HCl is a catalyst, its moles will not change even after several days. The 0.005 of HCl will get neutralized by 0.005. पीछे कितने बच गए?
0.04.
So एक तो ये हो गया. So what are the rest of the 0.04 moles reacting with? They're reacting it. I mean, the rest of the 0.04 moles are reacting with ethanoic acid, right?
Yes.
Munad, is this clear?
Yes, yes.
Okay. So they react with ethanoic acid. So how much ethanoic acid is actually left after several days? Based on this ethanoic acid or NaOH, they react in 1:1, right? So if only 0.04 moles of NaOH is reacting, right? तो एथेनोइक एसिड कितना बचा हुआ पड़ा हुआ है? 0.04 moles, right? Is that clear?
No, sir.
एक सेकंड, ये तो क्लियर है कि 0.04 moles, like you added
Oh,
point.
समझ गया।
अच्छा
Okay, sir, sorry, sir.
चल ठीक है, फिर से एक्सप्लेन वैसे मैं कर रहा हूँ कि you added 0.045 moles, right? You know NaOH is a base. You know that it reacts with the acids. There are two acids, right? And this is the catalyst, so its moles will not change. Uske moles change ho honge because that's undergoing a reaction, so its moles will be different, but this moles will not change. So you figure out that out of the 0.045 moles, 0.005 moles are definitely reacting with the HCl over here. Baki bache, the rest of the remaining 0.04 moles, those are the moles that are left. And you figure out that those moles will then definitely react with the ethanoic acid. So if 0.04 moles of NaOH are actually reacting, that means the amount of ethanoic acid will also be 0.04 moles. क्योंकि ये भी 1:1 में react करते हैं. NaOH and ethanoic acid react in 1:1. अगर वो 0.1 moles होते ना तो यहाँ पे you would have needed 0.1 moles of NaOH. But since only 0.04 moles of NaOH are reacting, that means the amount of ethanoic acid that's left at the end is 0.04 moles. Is that clear?
जी सर।
बाकियों clear है?
Yes, sir. Yes.
अब्दुल्ला clear है? मोमिन clear है?
Yes.
अच्छा तो उसने कहा था what amount of reacts with HCl? That's 0.005, right? The other part was write a balanced equation of ethanoic acid and hence calculate the amount of moles of NaOH that reacted. We did calculate that's 0.04. So अब अगला table बनाना, that's going to be easy. That we know that we added 0.1 moles and at equilibrium you're left with 0.04 moles. I mean, this is the equilibrium. This is the reaction that's happening, right? Ethanoic acid reacts with this, produces this and this, right? So now this turns into the normal KC question, which is you started off with 0.1 moles, but after several days, there's only 0.04 moles of ethanoic acid left. So कितना वो खत्म हो गया? 0.06 have reacted, right? So that means 1:1, so 0.06 of this would also be gone. So the moles of this will be 0.04 moles as well. And 0.06 will react with 0.06, and on the other side, it's going to produce 0.06, right? So 0 initially the, so 0.06 got produced, so you're left with 0.06. 0 initially, 0.06 extra got produced. So you found your equilibrium moles now in the mixture. And you can now just calculate the value of Kc. It's going to be 0.06 squared divided by 0.04 squared. Achha, do I need to calculate concentration in this case? Okay, मैंने कहा था कि Kc uses concentration, but do I need to calculate concentration?
Will they cancel out, sir?
It will, yes, exactly. But I told you that when Kc is dimensionless, like the moles on the right side and the moles on the left side are exactly the same, then the divide by volume part is kind of unnecessary, because even if you try to find concentration divide by volume, the numerator terms and the denominator terms, the V's in the numerator and the V's in the denominator are going to get cancelled out anyway. So there's no point in finding concentration in this case. And I don't think you can actually find concentration because he didn't give us the volume, right? Volume can be mentioned here, I guess. Yep. He didn't even mention the volume. So if we had taken it as V, I said, remember, otherwise, if agar the moles yahan pe different and the moles are different over here, then you have to, at all costs, you have to actually find concentration. But in this case, you don't need to find concentration. But only in this case, this is the only exception where you can directly use moles to find Kc. So that's it. Jo bhi answer aata hai, you'll get the answer. Is that clear?
जी sir.
Yes, sir.
So Baki, you'll have similar questions. This is type 2. We'll do type 2 in the next class. Assessing the mixture containing as they gave the Kc. So let's try and do this one. It's TK is asking. We're only doing questions where they're asking us to calculate the value of Kc. So 2 moles of O2 were placed in a container. So you had 2 moles of this, 2 moles of this, and there's no, I don't think there's any SO3, right? And it was allowed to reach equilibrium, and the equilibrium contains 1.98 moles of SO3. So you got 1.98 moles of. So you started off at 0. Now you've got 1.98. That means 1.98 got produced, right? Oh, plus like there's an extra 1.98. 2 get produced by 1. So यहाँ पे क्या होगा? How much O2 must have reacted?
0.99.
0.99, right? Because it's 2:1. So 1.98 getting produced. So that means 0.99 must have reacted. Or what that is 2:2. So that means if you produce 1.98, so यहाँ पे 1.98 is the amount that will react. So you'll be left with how much? 1.01 moles. And over here, it's going to be 0.02.
जी सर.
So Basti, you found you saying calculate the amount of moles of Kc. Do I need to find, if I want to calculate Kc in this case, do I need to find concentration in this case? Okay, should I use moles directly?
Sir, concentration निकालनी है.
You can remember up
Sir, because it's 40, sir.
हाँ, लेकिन ऊपर से वो terms equal नहीं है ना कि you got numerator में you have 2 moles and denominator में you've got 3 moles, right? So the volume part will not get cancelled out. So you have to find concentration at all cost. So 40 dm cubes है ना, you have to divide everything. The container volume is 40 dm cube. So you would actually to find Kc, okay? Remember, he didn't actually tell you to find concentration, but remember that. But this is one common mistake that people start using moles directly for Kc. There's only one exception where you can use moles directly, and that is when जब दोनों साइडों पे ना the number of moles are exactly the same. The numerator terms and the denominator terms are exactly the same. That is only when the V will get cancelled out. ये है 40 है, ठीक है. So Kc is going to be product 1.98 divided by 40, and that's squared, and divided by 0.02 divided by 40, and that's squared, and O2 that's 1.01 divided by 40, and that's 1 power 1. So नीचे 43 times आ रहा है, ऊपर what 42 times आ रहा है. So the 40 part is not getting cancelled out. Anyways, you can find the Kc yourself now. ठीक है, that's, and you can find the unit for Kc as well. It's going to be concentration. What's the unit for Kc? It's going to be concentration squared divided by concentration squared into concentration. So it's going to come out to be x to the power -1. So you can plug in mole per dm cube with the power -1. ठीक है?
Okay, sir.
So chalo, ठीक है. We'll continue in the next class. We'll do the other types of Kc questions, and where the key, this one is we just did one type of question, which is finding Kc. The other one is the Kc will already be given to you. ठीक है? तो वो फिर next class में करेंगे.
Okay, sir. Sir, ये recording भेज देंगे पूरे हफ्ते.
ठीक है, मैं वो फोल्डर शेयर कर देता हूँ. ठीक है?
Okay, sir.
Okay. Allah Hafiz.
Also sir,
Okay, sir. Thank you, sir.
सर ये वाला एनर्जेटिक्स का हमारा नेक्स्ट टॉपिक कौन सा?
नहीं, इसके बाद
उसके बाद
वो बताओ कब एग्जाम तुम लोगों का? ये जून है?
नहीं सर, मैं तो
May,
रिवीजन
June,
कर
sir.
रहा हूँ मेरा भी.
अच्छा,
जी
अच्छा.
इस साल का है. Sorry.
चलो मैं बताता हूँ. व्हाट्सएप में मैसेज करो, मैं I'll tell you. ठीक है?
All right sir, thank you.
ओके, अल्लाह हाफिज.
Allah Hafiz, sir.